A six-faced fair dice is rolled 5 times. The probability in percentage we have to calculate of obtaining 1 at least 4 times is. So in the problem it's given it's a 6-faced dice. So the number of possible outcomes for this dice, it can be 1, 2, 3, 4, 5 and 6. In the problem it's given this dice is rolled 5 times. Okay, so 5 times it is rolled and we need to find the probability of getting 1 at least 4 times. Okay, this is at least 4 times. At least 4 times. At least 4 times means it can be either 4 times or it can be 5 times. So here we can find the probability using binomial distribution. Okay, so binomial probability distribution. So why we are using binomial probability distribution? Because the binomial probability distribution model allows us to compute the probability of observing a specific number of successes. That means this, in this case 4 and 5 times getting 1 will be the successes. When the process is repeated, that means we are repeating this rolling of this 6-faced fair dice, right? In these cases we can use binomial probability distribution for the calculation of probability. Okay, now let's see what binomial probability distribution says. According to the binomial probability distribution, the probability of R successes in n trials can be written as P of R is equal to NCR P to the power of R into Q to the power of n minus R. Here Q is the probability of failure. Therefore, Q will be equal to 1 minus P. N is the total number of trials and R is the number of success in n trials. Okay. Coming to our problem. Now let's calculate the probability of getting 1 in single roll of the dice. Total possible outcome when a dice is thrown is 6. So probability of getting 1, let's write P1. In single time it will be 1 upon 6. Therefore, probability of not getting 1 in single roll of the dice Q will be equal to 1 minus 1 upon 6, which is 5 by 6. Now to calculate the probability of getting 1 at least 4 times in 5 throws. How can we write that? So to get 1 at least 4 times, that means either it has to be we have to get 1 4 times or we have to get it 5 out of 5 times, right? R is equal to 4 and R is equal to 5. So let's write here P R greater than equal to 4 will be equal to P of R is equal to 4 plus probability of getting 1 5 times out of 5 times. Now this we can write as, this will be equal to, using the binomial probability distribution we can write 5C4, that means 4 out of 5 times, P to the power of 4 to Q to the power of 4, 5 minus 4 that is 1 plus 5C5, that means getting 1 5 times out of 5 times, P to the power of 5 to Q to the power of 0, 5 minus 5 0. This will be equal to 5C4 is 5. P we have already calculated 1 by 6 to the power of 4 and Q is 5 by 6 to the power of 1 plus 5C5 is 1 multiplied by 1 by 6 to the power of 5 and 5 by 6 to the power of 0. So upon calculation we get the probability of getting 1 at least 4 times out of 5 times will be equal to 0.0033. Okay, and we have to calculate in percentage, So this will be equal to 0.33%. Okay. Be careful while marking this in the options or while filling the blank, because sometimes we don't usually calculate this percentage and make this mistake by writing this probability. We must check that in the problem it's given, we have to find the answer in percentage. Okay. So here the correct option is option C. For more insight in binomial distribution, you can refer to the NPTEL course lecture number 1, Discrete Probability Distributions on Physical Applications of Stoichiometric Processes by Professor V. Balakrishnan of the Department of Physics at IIT Madras.